All right, a couple terms to go over first. A polynomial. We talked about monomials a little bit in chapter 7. If you don't remember, go back to the 7.1 video where we talked about monomials. But a polynomial is a monomial or the sum of monomials. Remember, a monomial is kind of a one-term thing. It can be a product, that's okay, and it can contain variables and constants, but it can't have addition. Well, polynomials is where all those monomials get added together. So a binomial is the sum of two terms, terms being something that we use for to describe a singular monomial in a polynomial. So two terms or two monomials. A trinomial, I bet you could guess tri, meaning it's a sum of three monomials. Now the degree of a monomial is the sum of the exponents of all the variables. So for example, if we had 4x squared y cubed, this would be a degree 5 monomial because we have 2 plus 3. Because it's the sum of all of the variables. Now, the degree of a polynomial is the greatest degree. Of each of the terms. So if we had 2x to the fourth plus 4x squared plus 3x plus 2, the degree of this polynomial would be of degree 4 because that is the greatest degree of a singular term. Now, when we talk about polynomials and we have a standard form of a polynomial, this means that they are in least to greatest not least to greatest. They are greatest to least degree. So for example, this polynomial here, 2x to the fourth plus 4x squared plus 3x plus 2 is in order from greatest degree to least degree. Let's see, if we went 3x cubed plus 5x fifth plus 2x squared, that would not be in standard form. And the leading coefficient is the first coefficient when in standard form. So this right here has a leading coefficient of 2, Now, when we are finding the sum of sums and differences of polynomials, the thing we're going to do is we are just going to combine like terms. Now be careful, there's no multiplying happening. We did a lot of multiplying last chapter in chapter 7. Now in chapter 8 there's no multiplying, we're just combining like terms with the same variable and the same exponent. So if we're doing 7y squared plus 2y minus 3, that trinomial, plus 2 minus 4y plus 5y squared, we're going to look for combined terms. So I'm going to take 7y squared plus 5y squared and combine that to 12y squared. I'm going to take plus 2y minus 4y and get negative 2y. I'm going to get minus 3 plus 2 minus 1. 12y squared minus 2y minus 1. If we cared, in case we cared, this polynomial is of degree 2 and has a leading coefficient of 12. Now, looking at this difference, we have the trinomial 6n squared plus 11n cubed plus 2n minus the trinomial 4n minus 3 plus 5n squared. Careful with this grouping. I'm going to rewrite this as 6n squared plus 11n cubed plus 2n. I'm going to say plus negative 4n plus 3 minus 5n squared. That way I'm not confused with the subtraction and I can go to combine like terms again. So looks like 11n cubed is my only cube. 6n squared minus 5n squared is plus 1n squared, or just plus n squared. 2n plus negative 4n, I get minus 2n, and I'm left with plus 3. Also, in case we care, this is of degree 3 with a leading coefficient of 11. Now in our practice problems today, it's going to ask us to do two things, one of which being to write our polynomials in standard form and to identify the leading coefficient, and the other is to find the sum or difference. So on page 1095, 26 through 42 even, 26 says to write it in standard form, and we have 5x squared minus 2 plus 3x. So standard form goes from greatest degree to least. Our greatest degree here, we have 5x squared. Then we have plus 3x, then minus 2. And the leading coefficient, LC, that's going to be 5. All right, let's do one sum or difference. So let's look at 34. Where we have, let's see, 2c squared plus 6c plus 4, 2c squared plus 6c plus 4, plus 5c squared minus 7. So, we're going to take our terms that are the same and add them together. So 2c squared plus 5c squared, 7c squared, looks like plus 6c, plus 4 minus 7, minus 3. There we go. Have fun. Hopefully this isn't too bad.